for now. Carsten, I'll happily hand over to yourself and to Liz.
Great, thank you. Yeah, thank you for joining, everyone. I see there's a pretty good attendance here, so let's just get started. This presentation of this workshop is about an introduction to building on the Internet Computer in Motoko, and I will also be talking about our command line tool, a part of the SDK called DFX, and our programming language Motoko. I will be doing some coding here, and I will be sharing some code snippets and some commands. I use a MacBook, but if you're using another system, if you're using Linux or Windows, perfectly fine. You can still run and install our SDK. There may be some things you need to do, like if you use Windows, then run the commands in WSL2. If you have a newer MacBook with M1 processor, you may be needing to install Rosetta, but otherwise you should be completely able to run the SDK and the same code as I'm running here, regardless of what system you're on. I just wanted to mention this here in the beginning if you want to follow along. So what is the Internet Computer? I grabbed this very long sentence, which I think captures it pretty well from our website. The Internet Computer is a blockchain that enables developers to develop and deploy secure, autonomous, unstoppable, and tamper-proof software running at web speed and capable of scaling without limits. It's a very long sentence. It has a lot of words, and I think it pretty much captures it. But there are a couple of things that I want to highlight from the Internet Computer and what it does. One of the things about the Internet Computer is we can run everything on chain. That means you can run your front end, your back end, everything can run on chain. So you're not just storing or retrieving data or running simple operations on blockchain and then the rest somewhere else. You can run everything on chain here. We have a concept we call canister smart contracts. And what a canister is, it's really a component that encapsulates both the front end, the back end code, the dependencies that is needed to run the application, and the state of the dApp. And finally, Motoko, which I'll be using today, is a native language for the Internet Computer. But if you have a preference towards other languages, you can use that as well. As long as it can be compiled to WebAssembly, you should be okay. And this goes for the back end. For the front end, you have a large degree of freedom to choose whatever you have experience with and what you like to work with. Let's say you want to work with React or you want to use Vue. There's a large degree of freedom here. You can pick and choose more or less any front end language that you want, as long as we are able to compile it to WebAssembly. So let's take a look at the Canister SDK, because it's really core to everything we do when it comes to building and deploying our dApps. This is a very simplified flow, but it pretty much shows the flow of building and deploying a dApp. First, you create a project, and you use the SDK to create a new Canister project, a Canister smart contract project. Then you write your code, and then you deploy it. And when you deploy it, either locally, because you can run it locally, or to the Internet Computer blockchain, then you use the SDK again to deploy it. And installing the SDK is very simple. This is an example again from, I use a MacBook, so this is what I run in my terminal when I want to install the SDK. And with this SDK, you get the tools that you need to both create a new Canister smart contract project. You get all the tools that you need to maintain the project and to deploy it. Even after you deploy it, if you need to fill up your canisters with more cycles, or if you need to delete a canister or do some maintenance, you use the SDK for that as well. So it's very core to building and running a dApp on the Internet Computer. When you've done installing it, you can test to see if it's working on your system. just run the command dfx -- version, and it should provide you with the version number of the SDK or the DFX you installed. DFX, you will see that multiple times throughout this this workshop. This is the command line tool we use for creating our projects and to maintain and to deploy it. It's our command line execution environment, and there's a ton of different features in DFX. And after this presentation, I would recommend you to go to the Getting Started section in our documentation, where you can find a complete list of all the functionality we have in DFX. Let's take a look at Motoko. Most of you are probably new to Motoko, so I'll just go through some of the concepts of Motoko. We'll go deeper into it when I start to do some coding, and we'll build this small application. I think some of it will make sense when we do that. But just to highlight what is Motoko, it's a programming language that we developed specifically for the Internet Computer. It's native to the Internet Computer, and it's meant to be used for generating the next generation of decentralized applications. What it means is that if you use Motoko, there are some functionalities that you won't get in other programming languages, even though you can use others. Some that are closer to the environment it's running on. You can work with the canisters in a deeper way than if you were using Rust or other languages. So there are some benefits of using Motoko. Some of the concepts, very briefly, we use the actor model. It's not a new invention. It's not something we created. It's actually been around for a very long time. And the canister smart contract is expressed as an actor. It means it encapsulates both the state and the functionality of the backend. So you can see in the small code sample here on the right that we have the actor. In this case, we call it counter. You can have multiple actors in your application. You don't need to just have one big. You can split it up by functionality. Then we have a value. We save the state of the application here in the actor. And then we have a very simple function that can increment this value. We have something we call futures, and it's kind of similar to what you know as promises in JavaScript languages. And we run everything asynchronously. And we've actually taken some steps to make it a little bit simpler than what you may be used to. The callback hell will not really exist in Motoko. We can actually wait for a future to return before we go to the next step in our application. So it, in a way, it runs synchronously, but we do have the option to wait for calls before we go to the next step and get that returned as something similar to a promise. We call it a future. And then we have the memory persistence. I talked a little bit about it. In the canisters, we do save the state. It's a part of how the canister smart contracts works. We save the state, and this means that the state of the application is not something you need to restore or save to external storage. It's saved within the canister, and this works even across multiple nodes. So if your dApp is spread over multiple nodes, the memory will be persistent, and it will be the same throughout the application. So that's another feature built into Motoko. The way that we communicate to the outer world, let's say we want to use the same example, the increment function we looked at earlier, and we want to expose this to either the front end or maybe another canister, or maybe we want to expose this to another application that's outside our canister, that's outside our environment, kind of like you're used to maybe developing an API for your functions. All of that, we use our language Candid, which is an interface descriptive language to describe how to communicate with the Motoko backend in our canister. And it's in this example, we have the same increment function, and we can see here it doesn't take any arguments, but it returns a number. So everything on the backend side is exposed through the Candid interface. And when you're using Motoko, the Candid interface is automatically generated for you. You don't need to write these yourself. If you choose to use another language, let's say you want to build your backend in Rust, then you do need to create these Candid files yourself. And our documentation describes that very well, how you do that. But with Motoko, you get this out of the box. It generates it when you build your application. It will also build the Candid files for you. Okay, so let's get to the fun part. Let's build a dApp. The dApp we're going to build here is super simple. All it's going to do is it's going to put a button on the screen, and we have a counter, and every time you click the button, it counts one up. See, this is a very simple app. There's nothing magical or anything advanced in that, but it actually takes us through the different parts of building a dApp on the Internet Computer. First of all, we obviously have the front end here, and we have the back end that can provide the functions for the front end to count up. And then we have the Candid interface in the middle that makes it possible for the front end and the back end to communicate. And then we deploy it. We deploy it locally. So we also go through the process of learning how to deploy this dApp when we want to test it. So what we will do is that we'll create a new Canister smart contract using DFX. And when you do that, you get out of the box, you get a default project that has a very simple website that can take a name, and then it can write hello, and that the name you provided in a text box. And that template is something that comes every time you create a new Canister smart contract. We'll take that template, and then we just modify it to make it easier to get started and get something up and running. Because you get a lot of the things you need to actually build and deploy your dApp on the Internet Computer by using the default template. There's some configuration files and other things that you need, and that's just given to us. So why not use it? We'll add some backend functionalities. I'm just going to add 3 simple functions. I'm going to add a count that will count up every time it's invoked. That will be the same as clicking the button, and then we want to count the number 1 up. The get count is so the website can pull from the backend what is the current count number, and then there's a reset count. Then we're going to implement that backend in the front end, and we're going to deploy the Canister smart contract locally so we can test it. Both the backend, we'll test that in the Candid UI. We'll try to test the backend command line in our terminal, and then finally we'll test it in the browser to see if everything is working. So what we should learn from this is that we can use the SDK to create a Canister smart contract, and we figure out how we can test this and how we can modify the application and build upon the default template. I'm going to show you how to use the SDK for testing your backend, something that's very useful when you're developing. We'll create the backend functions in Motoko. So going through how we actually program in Motoko, and then finally implement the backend functions in the front end using just plain JavaScript, just to make it simple. Okay, so now I will change to my And I'm using VS Code, and you can use any code editor that you like. I would say there's one big benefit of using VS Code, and that is that we do support syntax highlighting, which makes it a lot easier to work in Motoko. So if you're going to build your application in Motoko, I highly recommend using VS Code just for the syntax highlighting. It makes it a lot easier. I'm just going to keep it here. I could use my terminal, but since the IDE here provides me a terminal, I'm just going to use that. The first step is we wanted to create a new project. So using DFX, I just assume that we already ran this step when we walked through the SDK and DFX. So DFX is already here. We can just test it. Yes, I'm running the latest version, which is 0.8.1. So now we want to create a new project. So let's try that. DFX new, and let's call this project hack. Okay. So now it's setting up the project and pulling all the necessary files. It should be fairly quick. Okay, that's done. Get this description of how to do it. Okay, so I'm just going to go into the directory here. If we look here, what was created was this sample project, this default project, and there are a lot of things that we need to actually deploy an application on the Internet Computer. DFX is a file that is very essential. All the DFX commands that we are running is looking for this specific file to make a decision of how to treat the command. And the dfx.json file describes where we find the different files, entry points for our canisters. You can see here that the canisters here are defined. We have two canisters. We have a hack canister and a hack assets canister. The difference is that we use the hack canister for our backend, and the hack assets canister, we use that for our front end. And all of this is given to us when we use that default project. At the bottom, we have which version of DFX we are running and what the localhost to bind to. Okay, if we look at the source, we see again, this is where the files are. We have the backend, we have the Motoko code here. And in the assets folder, we have our JavaScript files for the default project. Okay, so now we have that. Let's go and modify our backend. So there's already a function here, and what it does is it takes a text input and then it returns a text string inserting this. We don't really need that because we're going to build our own. And since we're going to build the counter, the first step is that I want to define a counter that we will use as our variable to keep track of the count we add. So let's say counter, and it's type. So we need to provide the type, and let's give it an initial value of 0. Then we need a public function, count. And we don't want to provide any values here, and we want to make it asynchronously. And we are returning a number again. And what we do in here is really simple. We just take the counter. Oh. and then we just increment it with 1. And when that is done, we just return it. Okay, that's a very simple function. Then we want to query. We want the front end to be able to ask, what is the current number? What is the current count? So let's create another one. Public function. But since this is a query, we're going to ask for, and we're going to ask for something. We have to specify that this is a query. And there are only 2 types. There's either a query or just a command or just a function we are calling. So in this case, it's a query, and we call that get count. We also want to make that async. So a number. And what we want to do here is we just return the number. Or return the counter. Very simple. And finally, we can delete this one. Let's make a function that makes it possible to reset the counter. And we want to return here we could actually just leave it by that, but let's just return the counter when it's completed. First, we set it to 0, and then we return it. Okay, so this is actually our backend. We have the counter. We have the variable that defines what count the current count, and this will be we will be saving the state. The canister will keep this as a state related to the actor. We have a function that just count the counter up with 1 and return it. And we have a function called getCount that will just return the current value of counter, and then we'll be able to reset the counter. So
hey,
this
Carsten.
is yeah.
Oh, sorry to interrupt. We have some questions in the chat, which I'll field over to you if that's okay.
Yeah.
So from Philip, he's asking, is the query keyword necessary if I want to return a list instead of a single element?
Yeah, if you're querying, you need to provide that. Yeah, I think
Great.
I think that it may be I think when you're querying some data or you want to return some data, yes, you need to add the query.
Great, Carsten. And then we had a conceptual question. I know that you might cover this later when you actually deploy, but the question from SIAG is, to summarize, right now this is all local deployment, or this is all happening locally, but once you deploy it, let's say you're like using the counter, like what part of that is blockchain? Like what is the transaction exactly happening on chain?
It's all of this is deployed on chain, so everything is running on chain. I don't know if that answered the question, but yeah, everything here is on chain.
Okay, and can you also explain very briefly? So I think there is somebody in the chat who's thinking that canisters run on chain. Can you explain how like the canister gets, like compiled down in the browser and how the transaction ends up on chain?
Yeah, well, very high level. The canister is a concept that makes it easier for us to understand like how we encapsulate all the code and the state. But what actually happens when we deploy is we take everything that we have in the canister, the front end, the back end, everything we did, we compile that to WebAssembly. And it's actually the WebAssembly file that we put on our blockchain. So So yeah, everything is compiled to WebAssembly and then executed on the chain as a WebAssembly file.
Okay, great, Carsten. Thanks very much. I'll let you know if I see further questions. And if anyone on the call has questions, definitely feel free to jump in. You know, the session is for you guys, so don't be shy. Yeah,
let's see. Okay, so now we have a backend, and it could be fun to test this. So when we're going to run our dApp on our local system, we need to have DFX running. So I'll just open up in a new terminal, and then I use the DFX command, DFX start. So you can also do that in the same, but if you want all the debugging messages, run it in a different terminal. But if you just want to run in the same terminal, you can have it run in the background by adding -- background. But in this case, it's easy for me to add another terminal, so I'll just do that. Oops. I have something running already. Let's see. Okay, so I actually have it running already. I shouldn't have. There we go. If DFX is already running, if you have the server running somewhere else, you'd need to stop the other one first, and that's what happened right here. Okay, so now this is running, and then here, if I write DFX deploy. We're creating a local wallet canister. So this is basically setting up a local version of the Internet Computer. And we're creating canisters. This should only take a very short time. While this is running, let's see, we can start to inspect some of the things that are happening here. Since we're running it locally, I'll look in the local folder, and there is a file here called canister IDs.json. And if we look at the canister IDs that are being generated here, we should be able to see them here as well. So this is keeping track of the canisters that we are deploying to. When we're going to deploy to the Internet Computer, we need to have these are local canisters. We need to replace these in a canister IDs JSON file with the canisters that we actually want to deploy to. So it's just a little information about how these canister IDs are stored. Okay, so now all the canisters have been created and they've been deployed locally. So now we should be able to try to use our backend. And if I go back to that file, what you can see here is a new folder has been created. And this is the candid files. Oh, this doesn't seem to be updated.
Hey, Carsten, we got a question in the chat around like what is happening right now and like what exactly is, are you waiting on or is not working currently?
Yeah, so, so what I'm trying to do is I'm trying to build the backend. And the reason I want to build the backend is I want to try to deploy it and then show different ways of testing a backend.
In the meantime, I'll just pop the links for the future workshops in the chat for anyone that hasn't signed up to those. We've got one on Friday, which is building in Rust. And there's also ones about building front end in the Internet Computer and some office hours as well.
And in the meantime, I'm going to drop in a link in the chat for the Motoko Playground. So essentially, if you wanted to experiment with building an application in Motoko, but if you didn't want to download the SDK, and if you didn't want to deal with like cycles and so on and so forth, that is a very, I think, friction-free way of getting started without thinking about all of these other things. So I just dropped the link in the chat, so feel free to check it out. And Carsten, we have some additional questions in the chat too. So to interact with the backend, like Motoko or Actor, in the front end, you use JavaScript?
Yeah, you can use JavaScript or any JavaScript-based framework.
Cool.
Let's see, this should work.
And we also got a question around, like with live demos, I think it's really normal to have to debug on the fly. I think this always happens. But we got a question from one of the participants here saying, could you kind of like narrate your thought process with the debugging to help the students? I think also like give them a framework of how to think through things in case they get stuck too.
Yeah. So even though this is a super simple application, I managed to get some errors here. It doesn't matter how simple it can be. But actually, what was wrong here, and now I got it. It's running and everything is working. What I did wrong here was actually first I forgot the semicolon. Actually, when I didn't see the, and hopefully I should see. Yeah, see here now we got the services exposed and candid. So my first mistake was I didn't save my main Motoko file. Very, very, very silly mistake. The second one is I couldn't get it to build because I had some syntax errors. And I was just going through and trying to see where it was. And it turned out that I had forgotten to add these semicolons at the end of the function. So I code in so many languages. Sometimes you forget these things. We use semicolons everywhere, as you can see, and it will not build if you forget one of them. And that was what we painfully experienced here. So, but now, good thing is we compiled. The canisters have been deployed. We can see the backend functions have been exposed through Candid, which means that now we can actually use this backend. So let's try to find the function call again. So what we do here is we use the effects and the canister functions they have. There's a call function, and what you provide here is hack, the name of the project we gave it when we created a new project, and then the function call. And now it works. It returns 0. Let's say we want to try the count. If you notice, when we are going to make an update, when we are changing something, the response time is slower. When we're getting something, it's a lot faster. It's just one of the Internet Computer's nature behaviors. So now we have counted one up, and if we use the get count again, we'll get the same. It's having the value 1, and let's try to reset it. And again, we're changing something, so it takes a little bit longer, and it's now 0. Okay, so now I am going to, let's see. Now I'm going to show you how we can do the same, but in a web browser. And if we go up here and look at, the canister IDs, we have a canister ID for the Candid UI. So if we take this one and go to a browser, let's use this one. So if I enter this one and then localhost, then I can go back and get the canister ID for the backend. go. Here we see the same backend functions, and we can do the same just by clicking a button. There. Then now the count is 1. Now the count is 2, and we can use the get count, and we can reset it all. So this is 2 ways that you can test your backend. Either you use it command line, or you use it you use the Candid UI. So that I feel the Candid UI can be very convenient when you have a lot of different functions and you just want to test it out. And if we had created a backend function that would take a value, you would have a text field where you could put that in. Okay, let's go back to the code editor. So what we want to do now, and I see we are a little bit short on time, I will go and make some changes in the front end. And that is in the hack assets. First, this file, this is the default template file. Actually, what I would recommend you to do is to run the dfx new and then a name, and then just try to write dfx deploy in the root of that folder. Then you'll see this application. But we don't need that for now. We actually want to keep the logo, and then we will keep the button from this project. And then I'm just going to rename this counter. Okay, I think that is all I want to do in the front end. So what we will be showing is a logo, we'll have a button, and we'll have a field where we'll show the counter value. Okay, so remember to save this. In the JavaScript file here, we have the standard function we already was supplied. We can reuse this, and we don't really need the input field, so we don't need to read any values here. And as you can see, the backend is imported here through the declarations. That means through the Candid file. In the Candid, if you see over here on the left side, the hack has a Candid JSON, JavaScript version, and that's the one we are importing here. So here we just replace that with counter. And we don't need. Yeah.
Carsten, there is a question in the chat. So Ashwin is asking, Carsten has coded return statements in all 3 functions, but why was only get count a query function and not the others?
That's the way I see it is if you're going to get the state or get data, then I use query. If I'm just going to, I don't know if that's a good way to explain it, but it is. I am using the query when I'm using data that is stored in the canister. I think that's the best way I can explain it. I would recommend looking up, there's a long description of when to use query and when not to use query in the documentation. I'll highly recommend reading that section. It explains it a lot better.
Thank you, Carsten. I'm going to drop that link in the chat.
Yeah,
so,
if you can find it, it really describes it. It is one of the concepts that you kind of have to get familiar with, and I think it describes it better than what I can just say right now. Okay, so now we have the button hooked up. One thing that I think we should have too is we get the initial value. So let's try to do that. Make a call to get the get number. What I want to do here is I just want to set up an event listener. So and I listen to when the front end is loaded. Is it done? And here we want to get the counter. Again, this is asynchronously. And then we want to update the element. And we add the value that we got. Okay, so this should work. If we look at this file really quickly, we import the backend functions through Candid by importing the JavaScript. We can actually take a look at it here. This is the file that we are importing. The functions are exported, so we can use them in the front end. And I just have two very simple events here. One is when the page is loaded, we call the get count, and then we put that out on the screen so we can show what the initial or what the current count is. And then we have event listener that listens to the button click, and it will count. It will call the count function, which will count the number 1 up, and then it returns the value, and we're going to put that out. There we go. Okay, so now we have this file. Let's try to redeploy again. This should only take a minute. So what you can see here, some of the content is already existing. So when we do deploy again, it will look for changes and just deploy the changes. Okay. So we want to go to the web browser and take a look at if this is actually working. What we do again is we go up into the canister IDs and look. This is a canister ID for the front end. So if we go back to the browser, and then, by the way, you can see that I have already some in my history here. When you deploy locally, they will always have the same canister IDs. So the IDs I have here will be the same for you if you deploy it locally. Okay, so let's look. Here we have this should show. Okay, let's see what's going on here. Cannot read the value. Let's go back and see. Let's see if we get this one. Make, let's see. Let's just see if we at least get this one right. But the good thing is, at least we got something running. And this is running from the canister, and this is the UI, the logo, the HTML file we show. Obviously, it's the button element as well. Oh, it's actually working. I don't know what was wrong before. Maybe I did the same mistake I did before and not saving it. But what we can see now is that we are, every time we click on the button, we're sending the request. So we send the count request, which counts one up, and then it's returning the value. Go back to the code editor. So here we could make it more pretty by inserting this one. Oh. But yeah, let's see. But basically, this is a small application that shows how to build a simple counter page. And yeah, there was quite a few hiccups along the way, but hopefully that will make you feel more confident when you start building on the Internet Computer that you know, things sometimes go wrong, and usually it's small things like not saving the files or forgetting a semicolon, but this is a little project we built just sitting here together. So I hope this was useful for you. I don't think I have time for any more. So I would say that you're getting a document that describes how to deploy this to the Internet Computer. What we've done so far is just deploying it to the local host. Actually, deploying to the Internet Computer is pretty simple too. Let's see, stop share. You use the same DFX deploy command, but you just add your target, and in this case is the Internet Computer. So you would just add -- network space IC. Then you specify that you're going to deploy it to an Internet Computer. There are different ways that you can load cycles to your wallet. And those are described in the document you'll get as well. The way that you are being charged for running your applications or your dApps on the Internet Computer is that we burn cycles. So you have to load your wallet, or you have to load your canisters with a number of cycles. And there are different ways of doing that. In the document that you'll get, it will walk you through how you can do it either by signing up to our cycles faucet, which give you $20 free $20 worth of free cycles. Or if you have ICP, you can use Coinbase to purchase ICP, and then you can mint it through the DFX and add the cycles either to a wallet, or you can add it to the canister directly, and then you can deploy it to the Internet Computer. I think that's all I have time for. So if you have a few questions we can squeeze in before we end here, please let me know.
Cool. Thank you so much, Carsten, for that wonderful walkthrough. So just a reminder for everyone on the resources for this hackathon. So I just dropped the hackathon developer guide in the chat. Definitely bookmark it. Carsten spent, I think, many hours writing this specifically for this hackathon. It's very, very thorough. We'll walk you through like front to back everything that you will need. And at the very end, we've compiled a list of like resources that will be helpful for you guys in terms of like tooling, but also a lot of example code. So like full-fledged applications already running on the IC. You can definitely feel free to fork these if that would be helpful for you in terms of getting started. But we have a couple of examples in the categories of NFTs and gaming, so definitely check that out. If you have any questions, yeah, go ahead.
I just want to say one thing. If you go to forum.dfinity.org, there's a developer forum. There's a lot of helpful people. I go there on every day too to help out developers. And our Discord server, it's called DFINITY Dev Official. Those two are very highly recommended. If you get stuck, there are a ton of people on there ready to help you. So both the forum and the Discord, highly recommend going there if you run into any issues. Usually people are very responsive, but you get an answer pretty quickly. So I just want to mention that is in the link in the document as well.
Excellent. Yeah, and I just included the invite link to the DFINITY developer Discord in the chat. So as Carsten mentioned, definitely join that. We've created a special channel for you guys, which is #Encode-Hackathon. So if you have any questions, we have a ton of super experienced developers, both from the DFINITY Foundation, but also part of the community who can help troubleshoot you in Motoko and Rust on the front end. And of course, you can always DM me on Discord as well. So thank you again to Carsten for this wonderful presentation. Thank you everyone for attending, and I can turn it back to the Encode Club organizers.
Awesome. Thank you very much from our side as well, Carsten. I'm sure everyone has found it very useful, and particularly the debugging help as well. But yeah, I've just put some links in the chat. So some of the Encode socials, such as the Discord, which is a great place to find teammates. And there's also, I think Liz just put, the developer DFINITY Discord, which is a great place to go for the development help, as well as the DFINITY forum. And also, I will just paste again in case anyone's missed it. There's some more workshops coming up as part of the hackathon. So we do have the intro to building on the IC in Rust on Friday at 5, same time as this. Then next week, we'll be having sessions on Monday and Wednesday as well. One of them is on building a front end in the Internet Computer, and the second one on Wednesday is office hours, in case you have any questions. So yeah, I think that's pretty much it for today. This recording will be live on YouTube, as well as a Medium article with the slides and helpful links as well, going live tomorrow morning in probably about 16 hours. So yeah, keep your eyes on the Encode Twitter and Discord, and we'll also send that out via email once it's live. But yeah, thanks again, Carsten, and also to Liz as well for your support in the chat, and see you all on Friday.
Bye, everyone. Thank you.